Part 2 of the chemicals of life. All right, so we left off talking about atoms and what they're made of. There's some atomic particles, all that. So let's talk about those valence electrons and chemical bonding. So what do you think chemical bonding is? It's the sharing of a pair of valence electrons. Excuse me. So for example, H2. Hydrogen 2 means 2 hydrogen atoms. So if you look, you start out with 2 individual hydrogen atoms. But they're drawn together. Think sort of like a magnet drawn together. They want to get to where their valence electrons are being shared. Because here's the thing, there's this thing called the octet rule. So with hydrogen, they only have one cloud ring. And in that cloud ring, they can only hold 2 electrons. So by them sharing each outer electron, which they each have 1, would give them a full outer shell, and they're happy like that. Okay, so I'm just going to let you read through that. We just talk through it. So when they're shared, they're a covalent bond. Okay, covalent means sharing. So when a molecule consists of 2 or more atoms held together by covalent bonds, a single bond is sharing 1 pair of electrons. Okay? A double bond is sharing of 2 pairs of valence electrons. So if you look at the multiple covalent bonds, look at A where you have your 2 individual hydrogen. All they're sharing is 1 pair, 1 from each hydrogen. Okay, if you look at B, oxygen has double covalent bonds. So it's sharing 2 pair of those valence electrons. Okay, 2 from one atom, 2 from another. And that way they get to where they're stable and they're happy. So if we look at compounds and covalent bonds, water, everybody knows water. Everybody knows the chemical formula for water is H2O. 2 hydrogens, 1 oxygen. So if you look at the diagram, on the outside ring of that oxygen, it's sharing 1 electron with the hydrogen, and the hydrogen sharing its 1 electron with the oxygen. Same on the other side. So you need 2 hydrogen to satisfy that octet rule for the oxygen. It wants a total of 8 electrons in its outer shell. Now, if you look at methane, which is CH4, you have your 4 atoms of hydrogen, okay? And that is what's going to satisfy the valence electrons of the carbon, okay? That way, that's what's going to make that methane. So when we talk covalent bonding, we also have to think about the charge of the atom. So electronegativity, it's the attraction of a particular kind of atom for the electrons in a covalent bond. Okay, the more electronegative an atom is, the more strongly it pulls shared electrons towards itself. So if we were talking a non-polar covalent bond, the atoms have similar electronegativity, and they share the electron equally. So when they get put together, it's not more one way or the other. They're sharing it right down the middle. In a polar covalent bonds, the atoms are going to have different electronegativities. So it's going to share that electron unequally. Think water. Okay? So each hydrogen has a plus charge, whereas the oxygen has a negative charge. Okay, and it's what draws them together. Now, instead of covalent bonds where they share the electrons, let's talk about ionic bonds. In some cases, atoms strip electrons away from their bonding partners. Okay, electrons can be transferred between the 2 atoms to create ions, hence the ionic bonds. So ions are atoms with more or fewer electrons than usual. Ions are charged. They're either positively charged or negatively charged. So we know an anion is a negatively charged ion. A cation is positively charged. So if you look at sodium plus, which tells us it's the cation, okay, and then you have your chloride, which is your negative ion, okay? So what do we know about opposites, positive and negative? They attract, okay? So the slight repulsion of like negative charges happens, okay? So what does that mean? Let's look at it a little closer. So we know an ionic bond is the attraction between anions and cations. So when you look down at the picture, the lone valence electron of sodium is transferred to join the 7 of the chlorine. So sodium has 1 valence electron, chlorine has 7. In order to make that octet rule where that chlorine is going to be happy, it needs 1 more electron. Okay, so once it does that, it pulls that outer shell from sodium, okay, and sodium's now going to become positively charged, okay? And since chlorine took that electron, it's now negatively charged. So I want you to think, ionic compounds are often called salts because they form crystals. So a couple other types of weak chemical bonds. We've talked covalent, which is sharing. We talked ionic, which is transferring. Let's talk hydrogen bonds. Hydrogen bonds form when a hydrogen atom covalently bonds to one electronegative atom, okay, and is also attracted to another electronegative atom. Meaning what? Think of water, okay? The hydrogen bond results from the attraction between the partial charge on the hydrogen atom and the partial negative charge on the nitrogen atom for ammonia. So when you look at water, you have your slightly positive hydrogen is being attracted to your oxygen with the negative charge. Same's going to go on with ammonia. Van der Waals. Okay, so van der Waals interactions. That occurs when transiently positive and negative regions of molecules attract each other. So I want you to think the hydrogens are positive, but they're a weak positive. Oxygen is a weak negative charge. So what's going to make it bond to other water molecules? Those positive and negatives are going to attract other molecules. So these weak chemical bonds have a couple functions. They reinforce the shapes of the larger molecules, and they help molecules adhere to each other. Okay, now let's get into shape and function. Big thing you've got to learn, like highlight it, star it, whatever you need to do. Structure determines function. When you look at the chemical makeup of a molecule, what its structure is determines what its function is. Okay, the precise shape of a molecule is usually very important to its function. It's determined by the positions of its atoms' valence orbitals. See how this is all starting to build and how everything comes together? So when you start talking about chemical reactions, that's what make and break your chemical bonds. Okay, a chemical reaction is the making, breaking of chemical bonds. It leads to changes in the composition of the matter. So if we look at the reactants of 2H2, and you're going to add the reactant, oxygen 2, your product's going to be 2 molecules of water. Convert reactants to products. That's what that is. Okay, so that's the end of the slideshow. That's the end of chemistry and the structure of life. And that's just an overview. We could get a lot more deeper and intense into it. If you have any questions, please bring them up when we have the class Google Meet, and I'd love to discuss this with you.